today we are going to quickly revise chemical bonding. For ICSE class 10. So first we see what is chemical bonding. Chemical bonding is nothing but it is a force of attraction which is holding two atoms together. So let us say this is an atom A and this is an atom B. So the attraction force or the force of attraction which is holding these two atoms together can be named as chemical bonding. So now let us see why the atoms of different elements participate in bonding. So understand chemical bonding. So first you should know electronic configuration of the elements. Here electronic configuration is nothing but the distribution of electrons. Distribution of electrons into the shells of the elements. See, for example, when you take an element like carbon, carbon's atomic number is 6. So it will have 6 electrons and 6 protons. So in chemical bonding, we only discuss about the arrangement of electrons. So electrons are going to take part in the chemical bonding. So we are not talking about the protons. So only we see the arrangement of electrons here. So where carbon has 2 electrons in the K shell, that is the first shell, and 4 electrons in the L shell, that is the second shell. So this is the distribution of electrons and which is named as electronic configuration. And if you take another element like sodium, here it is 281 because sodium's atomic number is 11. So 11 electrons are there. So in K shell 2 electrons, L shell 8 and M shell 1. So here you have to remember K shell can have maximum of 2 electrons, L shell can have maximum of 8 electrons and M shell have maximum of 18 electrons. Okay, until it is the or it should be the one of the shells there. But otherwise, if M shell is the valence shell, it can have only 8 electrons here. So one thing you have to remember, valence shell can have maximum of 8 electrons. Like if you see calcium 2882. So in this case, calcium has atomic number 20. That means 20 electrons should be distributed. So KLMN. So here maximum electrons in M shell can be 18, but in this case if you add these 2 electrons here, it becomes 2, 8, 10. So it is not possible for any element to have 10 valence electrons. So that's why here M can have 8 electrons and the remaining 2 will go to N shell. Right? So this is the electronic configuration of different elements. Now in this we have 2 types of electronic configuration, that is stable electronic configuration and unstable electronic configuration. Stable electronic configuration means either the valence shell is complete, or if the element has 8 valence electrons. So under 2 conditions we can say an element has stable electronic configuration. One condition is the valence shell has to be complete and there should be 8 valence electrons. See, for example, when you take noble gases like helium, neon, argon, krypton, etc. Helium can have maximum 2 electrons in K shell, and helium's electronic configuration is 2 electrons in K shell. So now K shell is completely filled. Now helium cannot take any more electrons, so we can say this is stable electronic configuration. Similarly, neon 2, 8. So it has 8 valence electrons, so it is stable, and argon also 2, 8, 8. So this this also has 8 valence electrons. So we can say noble gases have stable electronic configuration. So we have 7 periods. In 7 periods, hardly we have 7 noble gases, and only 7 noble gases have this stable electronic configuration. And remaining all elements, rest of the elements in the periodic table, they all will have this unstable electronic configuration. Like carbon 2, 4, it is unstable. Sodium 281, this is also unstable electronic configuration. And calcium 2882, this is also unstable electronic configuration. If they have complete valence shell, or if they have 8 valence electrons, only in that case we can call it as stable electronic configuration, and those elements will be chemically stable. Like noble gases are chemically stable because of the stable electronic configuration. So they do not participate in the chemical bonding. Noble gases do not participate in the chemical bonding because they have stable electronic configuration. But what about rest of these elements? These elements, since they have unstable electronic configuration, they participate, elements with unstable electronic configuration participate in chemical bonding. Chemical bonding. And what is the purpose of involving or participating in chemical bonding? To attain stability. To attain stability. So the purpose for the elements to participate in chemical bonding is to attain stability. So that is the reason why elements are participating in chemical bonding. So now in this chemical bonding, mainly we discuss about 3 types of bonds. One is covalent bond, second one is ionic bond, then third one is coordinate covalent bond. So we'll see one by one. Let's see first type of bond, that is covalent bond. The first point what you have to remember in this covalent bond is, this bond is formed between non-metal and non-metal. That means between 2 non-metallic atoms, covalent bond is possible. Like if you take identical atoms, it can be identical or different kind of atoms. When you see hydrogen bond hydrogen, hydrogen is a non-metal, and this is also hydrogen, that is a non-metallic atom. So this will be a covalent bond. We'll see how it is possible. Similarly, chlorine bond chlorine, oxygen double bond oxygen, nitrogen triple bond nitrogen. So we'll see why single bond, double bonds and triple bonds are formed here. This is when you take identical atoms. And if you take different kind of atoms like H, hydrogen and chlorine, bonding between hydrogen and chlorine, both of them are non-metals, so it should be covalent bond. Then water molecule, that is hydrogen, oxygen bond, hydrogen. So one oxygen, 2 hydrogens. Then ammonia molecule, NH3. So where you have the bonding between nitrogen and hydrogen atoms like this. And then methane, 1 carbon combines with 4 hydrogen atoms. So in this case, all these elements are non-metals, and those non-metals are forming bonding between them. So this will be a covalent bonding. Now, what is the definition of covalent bonding? And how is it formed? Covalent bonding is nothing but mutual sharing of electrons. Mutual sharing of electron or electron pairs between the atoms where both atoms contribute equal number of electrons. Both atoms will be contributing equal number of electrons. Like if you take these pairs X, Y and A, B, randomly I am taking P and Q. Let us say X, Y together forming a covalent bond. So if X is contributing 1 electron, Y also contributes 1 electron. If A is contributing in this pair, A is contributing 2 electrons, B also contributes 2 electrons. So the atoms which are participating in the covalent bonding, so both the atoms will contribute equal number of electrons and they share them mutually. So here if P is contributing 3 electrons, Q also contributes, means from Q also 3 electrons will be participating in the bonding. So let's see some examples. And the purpose of formation of chemical bonding is to attain stability. So now the question comes, so which element contributes how many electrons? So just you have to see what is the electronic configuration of that element, so that you can see how many electrons that atom or element is going to contribute. So for example, when you take chlorine 287, it has 7 valence electrons, means it needs one more electron. One more electron for stability. Since it needs one more electron for stability, when chlorine participates in covalent bonding, it gives one electron. Okay, so chlorine atom, each chlorine atom contributes one electron in covalent bonding. So how many more electrons that particular nonmetal requires? So those many electrons will be given by that nonmetal for the covalent bonding. Let us see for another example, oxygen 2,6. It has 6 valence electrons. For stability, it requires 2 more. So that it becomes 6 plus 2, 8. Here 7 plus 1, 8. So already we have discussed stable electronic configuration. Either the valence shell is complete or 8 valence electrons are there. Then it becomes stable. So here 6 are there. It needs 2 more electrons. Oxygen atom needs 2 more electrons for stability. So it contributes, each oxygen atom contributes 2 electrons for covalent bond. Chlorine contributes 1 electron because it needs only 1 electron. Similarly, oxygen needs 2 more electrons. So oxygen contributes 2 electrons for the covalent bond. Similarly, when you take nitrogen 2,5, so 3 more electrons required. So it can contribute 3 electrons. Each nitrogen atom contributes 3 electrons. And when you take carbon, its electronic configuration is 2,4. So it is 4 plus 4, 8. So it requires 4 more electrons. So if you add 4 electrons over here, it becomes 2,8 and it becomes stable. So if you see the electronic configuration, you can determine how many electrons that each atom of that particular nonmetal is going to contribute for the covalent bonding. And when you look at hydrogen atom has only 1 electron. Hydrogen has only 1 electron in the case shell. So maximum how many electrons it can contribute for stability or in the formation of covalent bond? This one electron. So hydrogen atom can contribute only one electron for the stability. Right? So these points you have to remember before we start chemical bonding or to show covalent bond in different cases. Let's see some examples. So in ICSE class 10 board exam, we only focus on electron dot diagrams. Only electron dot diagrams we have to focus. So electron dot diagrams we are going to discuss now. In case of covalent bond, covalent molecules. Okay, example 1. Hydrogen molecule. Hydrogen molecule. We write hydrogen molecule as H2. So this is the molecular formula of hydrogen. Hydrogen molecule. That means two hydrogens are participating in the bonding. Two hydrogen atoms. So this is one atom of hydrogen, this is another atom of hydrogen. So this has one electron, this has one electron. So in electron dot diagram, you will show the electrons present in the valence shell like this. So this indicates the number of valence electrons or the valence electrons present in that particular element. Now, as I told you already, hydrogen has only one electron. Each hydrogen atom has only one electron. So this can give one electron from this hydrogen, and from this hydrogen one electron comes for the covalent bond. So now it looks like these two electrons belong to this hydrogen, at the same time this hydrogen as well. So now if hydrogen has two electrons in the K shell, in case, so this becomes stable. Okay, so now in this case, those two electrons belong to this hydrogen and they belong to this hydrogen as well. So now what happens? Each hydrogen will be feeling like it has two electrons in the K shell. So it becomes stable. So in this way, hydrogen molecule is stable with this one covalent bond. So now here in this case, one pair of electrons are being shared. So this will be one single bond between two hydrogen atoms. So this is a single covalent bond. Single covalent bond. Okay, so this is example 1. Let's see example 2. That is chlorine molecule. Example 2. Chlorine molecule. Molecular formula of chlorine molecule is Cl2. That means two chlorine atoms are participating in the bonding. Right. So chlorine molecule, again in this case also two chlorine atoms are participating. Let's write the electronic configuration 2, 8, 7, and this is 2, 8, 7. So now we are going to show only the valence electrons. Only valence electrons will be shown in this electron dot diagram. Remember that. So 7 valence electrons of this chlorine, 1, 2, 3, 4, 5, 6, 7. For this chlorine, same thing. 7 valence electrons are there. 1, 2, 3, 4, 5, 6, 7. Now each chlorine atom short of 1 electron. So this requires 1 more electron. This chlorine also requires 1 more electron. So from each chlorine atom, 1 electron comes to form covalent bond. So between these two chlorines, 1 electron is coming from this chlorine and 1 electron is coming from this chlorine. So this is a pair of electrons which is participating in the covalent bond. Other than that, this chlorine still has, out of 7, only 1 electron is involved in the bonding. So remaining 6 will be with this chlorine only. So you have to show it, it's mandatory. So this chlorine has those 6 electrons which are not participating in the bonding. Similarly, this chlorine also, out of 7, 1 electron is here. Remaining 6 will be with this chlorine only. So these 6 electrons are not participating in the bonding. So now here you can see only one pair of electron is being shared. So this will be one single covalent bond between those two chlorine atoms. So this is the formation of chlorine molecule. So you will get, if any diagram for any compound, definitely it will be this electron dot diagram. And you have to remember, in each molecule or in each compound, how many electrons are getting involved. Okay. In hydrogen molecule, one pair of electrons are involved. Similarly, in chlorine molecule also, one pair of electrons are involved in the bonding. In the bonding, how many electrons are involved? So that is example 2. Now example 3. Oxygen molecule. Oxygen molecule. Molecular formula of oxygen is O2. So in this, 2 oxygen atoms we need to take. Let's write the electronic configuration. If you write the electronic configuration, it will be easier for you. So that you can see here only how many electrons are there, how many more electrons it requires. 6 valence electrons. So we put 6 electrons here. 6 electrons. And here also 6 electrons. This oxygen atom. So both are oxygen atoms. They will be identical in electronic configuration. Now, how many electrons that each oxygen is contributing or giving for the covalent bond? So this is 2,6. This oxygen requires 2 more electrons. Even here, this also 2,6. This also requires 2 more electrons. So each oxygen requires 2 more electrons. So each oxygen will contribute 2 electrons for the covalent bond. So we put 2 oxygens next to each other. This oxygen is giving 2 electrons for bonding, and this oxygen also giving 2 electrons for bonding. Okay, total 2 pairs, 4 electrons, 2 pairs are in the bonding. But out of 6, this oxygen is giving only 2. Out of 6, this oxygen is giving 2. So remaining 4 remains here. Remaining 4 will remain here. Similarly, the same thing happens with this oxygen also. Out of 6, 2 are participating in bonding. So remaining 4 will be here. Now when you look at the electron pairs in the bonding, there are 2 pairs of electrons participating in the bonding. So when there are 2 pairs of electrons in the bonding, we say it is a double covalent bond. Double covalent bond. So in oxygen molecule, there are 4 electrons or 2 pairs of electrons participating in the covalent bonding. So this is the electron dot diagram of oxygen molecule. Right. Next, example 4. We'll see nitrogen molecule. So this oxygen nitrogen molecule, these two are important because we have double bond and triple bond. Example 4, nitrogen molecule. Molecular formula of nitrogen is N2. So two nitrogens are participating in the bonding. So when you understand the formation of chlorine and oxygen, it will be easier for you to understand this one also. 2, 5, 2, 5. So this has 5 valence electrons, this has 5 valence electrons. So 1, 2, 3, 4, 5, and even this nitrogen also will have same electronic configuration 2, 5. So 5 valence electrons here, 5 valence electrons here. So they require 3 more electrons here, 3 more electrons here. Each nitrogen requires 3 more electrons for stability. So each nitrogen will contribute 3 electrons. So from this nitrogen 3 electrons come forward for the covalent bond, and from this nitrogen also 3 electrons will come forward for the covalent bonding. And out of 5 each nitrogen is giving 3. So each nitrogen will be left with one pair of electrons which are not participating in the bonding. So 3 pairs are being shared here. So there will be triple bond between 2 nitrogen atoms. So this is how nitrogen molecule is formed. Right. So in nitrogen molecule, you will have a triple bond and total 6 electrons or 3 pairs. Okay, so this is called triple covalent bond. Triple covalent bond, or simply we can call it as triple bond also. Right. Next, example 5. Example 5 is water molecule. We know the molecular formula of water, that is H2O. So here you can see 2 hydrogens and 1 oxygen you need to take, because H2O we know the formula, that is H2O. And here electronic configuration 1, this is 1 and this is 2, 6. So here hydrogen has 1 electron, hydrogen 1, oxygen has 6. So here what we do is, so if you show the electrons of hydrogen with dot, okay, 1 electron here, 1 electron here. Now coming to oxygen, 6 valence electrons are there. So 6 electrons you have to show around oxygen. Now when you are taking 2 different elements, so for one element you will take dots and for the other element you are taking cross. Okay, so 6 electrons are here, so we put 6 cross over this oxygen. Okay, it is compulsory when you have 2 different elements, one should be dot, the other should be cross to represent the electrons. Right. So now here oxygen requires 2 more electrons, so oxygen is ready to contribute 2 electrons. But each hydrogen can contribute only 1 electron. And we have a condition. What is the condition? The atoms participating in the covalent bond should contribute equal number of electrons. If this hydrogen is giving 1 electron, oxygen also should give 1 electron. The same way, this hydrogen is giving 1 electron, this oxygen also gives 1 electron. So in this way, oxygen can contribute 2 electrons in the covalent bonding. But these 2 out of 6. So remaining 4 will be on the oxygen atom only. So when we talk about these molecules or compounds, you will see these electrons which are not participating in the bonding. So these are called lone pair of electrons. Very important definition, lone pair of electrons. In previous example also we had this lone pair, but only in case of water molecule and ammonia molecule we talk about this lone pair. So what is the definition of lone pair? Lone pair is nothing but a pair of electrons not participating. It is not involved. It is not involved. It is present on the atom. Not participating in covalent bond. It is not participating in covalent bond. So in this water molecule, very very important question. Many times it was asked in question paper, board exam. So in water there will be two lone pairs. Two lone pairs. So this is one lone pair and this is another lone pair. So two lone pairs, and both the lone pairs will be an oxygen atom. Both the lone pairs will be on the oxygen atom. On oxygen atom, and two covalent bonds. So here there is a covalent bond with this hydrogen and one covalent bond with the other hydrogen. So two covalent bonds. Two covalent bonds. So this is very very important one. So definitely there will be one question related to this lone pair of electrons every year. Right, so this is example 5, that is water molecule. So in water molecule you will have two covalent bonds. It is just two covalent bonds. Okay, it is not double covalent. It is not double covalent. They are single covalent bonds. Okay, one bond here and one bond here. These are two single covalent bonds. You can't call it as a double bond. This is a double bond, this is a triple bond. So this is a single bond, this is a single bond. Okay, don't call this as a double bond. It is a single bond here, single bond here. Two single bonds we can say. Right, next example. Example 6, that is ammonia molecule. Ammonia molecule, we know the formula, that is NH3. So NH3, you are going to take one nitrogen and three hydrogens. Three hydrogens. Electronic configuration 2,5. For nitrogen, for hydrogen 1, 1. So nitrogen has 5 valence electrons. So nitrogen 5 valence electrons we show here, 5. Each hydrogen 1 electron. So cross, cross, cross. Okay, because for nitrogen I am taking dots, for hydrogen I am taking cross in this example. Now, nitrogen requires 3 more electrons. Because it has 5 valence electrons, it requires 3 more electrons. Okay, it requires 3 more electrons. So nitrogen contributes 1 electron. Sorry, nitrogen contributes 3 electrons for the bonding. But here what happens, because this hydrogen is giving 1 electron, so with this nitrogen can form only one bond with 1 electron. This hydrogen can give 1 electron and nitrogen gives 1 electron. Similarly, this hydrogen gives 1 electron and this nitrogen gives 1 electron. So totally 3 pairs of electrons will be shared. But nitrogen is contributing 3 only out of 5. So still there is 1 pair of electron left. So this is called lone pair. That means in ammonia molecule, there is one lone pair. There is one lone pair on, where is it? On nitrogen atom. Okay, so where is that lone pair present? That is also very important. It is on nitrogen atom. And 3 covalent bonds or 3 single covalent bonds. 3 covalent bonds. Okay, so this is the ammonia molecule. So 3 covalent bonds. It is not a triple bond. It is just 3 covalent bonds. Single bond, single bond, single bond. So 3 single bonds are there. So this is called 3 covalent bonds. Next example. Example 7. Example 7, that is methane. Methane molecule, that is CH4. So one carbon, 4 hydrogens. So if you understand all these examples, it is nothing, it is just easy. So one carbon with 4 hydrogens. So electronic configuration of carbon 2, 4, hydrogen 1, hydrogen 1, hydrogen 1, hydrogen 1. So carbon will have 4 valence electrons. So 4 valence electrons we show here. Each hydrogen has only 1 electron. Okay, each hydrogen has only 1 electron. So since you have 1 carbon, 4 hydrogens, we keep carbon in the center, surrounded by 4 hydrogen atoms. Okay, so this carbon gives 1 electron because hydrogen also gives 1 electron. So here 1 electron from carbon, 1 from hydrogen, 1 from carbon, 1 from hydrogen. So I am showing electron from carbon as dot, electron from hydrogen as cross. So 1 electron from carbon dot, 1 from hydrogen, that is cross. So in this case, there are no lone pairs. All are covalent bonds. 4 covalent bonds, but 0 lone pairs. No lone pairs. No lone pairs in methane molecule. Right, so this is about covalent bonding. Now let's see coordinate covalent bond. Second type of bond. Coordinate covalent bond. So this is just a consequence of having a lone pair. Okay, so this is a consequence of presence of a lone pair. That means if any molecule has a lone pair, so that will be participating in this coordinate covalent bond. So already we have discussed 2 molecules, that is water molecule with 2 lone pairs and ammonia molecule with 1 lone pair. So these molecules will be participating in the coordinate covalent bond. So from water molecule you will get hydronium ion, and from ammonia molecule you will get ammonium ion. So from water you are getting hydronium ion, and from ammonia you will get ammonium ion. So we'll see how these 2 ions are obtained by coordinate covalent bond. So when water combines with H plus, okay, we learn in acids, when you put an acid HCl, H2SO4 something in water, first the acid produces H plus, and then H plus combines with water to give hydronium ion. Okay, so like for example, if you take HCl and if you dissolve water, HCl becomes or breaks into H plus Cl minus, and this H plus combines with water and finally gives H3O plus. So let's see how this bonding or how this H2O combines with H plus. Now let's write the electron dot diagram for water molecule. So for water molecule, so oxygen is contributing 2 electrons with 2 hydrogens to form 2 bonds, and oxygen is left with 2 lone pair of electrons plus hydrogen ion. Hydrogen contains only 1 electron, and when this 1 electron is lost, then hydrogen becomes hydrogen ion. So H plus does not contain any electrons. So that's why what happens, this pair of electrons will be given by oxygen to this H plus. So in this case, only one atom is contributing both the electrons. Okay, so only oxygen atom is contributing both the electrons, that H plus is not contributing any electrons. So the bonding is possible like this. So this is the actual molecule of water, and this H plus comes here and forms a covalent bond with this. It is a covalent bond, but where both electrons are coming from the same atom. So that's why it is called coordinate covalent bond. And there is a positive charge here. So this whole group of atoms or radical will take that positive charge. So in this case, these two are covalent bonds. These two are covalent bonds, but this is coordinate covalent bond. Coordinate covalent bond. So this is how hydronium ion is formed. Okay. Similarly, we'll see ammonium ion. When water molecule combines with H plus, it forms hydronium ion, and similarly when ammonia molecule combines with H plus, it forms ammonium ion. Okay, formation of ammonium ion. So in this ammonia molecule combines with H plus to form NH4 plus 1 or plus. So in this case, ammonia has 3 bonds between nitrogen and hydrogen with 1 lone pair of electrons. Now this is combining with H plus. So again H plus 1 or H plus does not contain any electrons. So this pair of electrons will be given to H plus and a covalent bond will be formed. Okay, so this is also sharing of electrons, but both electrons are coming from the same atom. So here you will have these covalent bonds and one coordinate covalent bond, and since there is a positive charge, the whole radical gets that positive charge. So in this you have 3 covalent bonds, this and this will be coordinate covalent bond, one coordinate covalent bond. Right. So this is about covalent bond and coordinate covalent bond. So next we have ionic bonding. Ionic bonding, which is also called electrovalent bond. Electrovalent bond. So in this bonding is formed by the transfer of electrons. And how the transfer takes place? From a metal to a non-metal. That means in this electrovalent bond, one metal and one non-metal will take part in the formation of this electrovalent bond. So let's see one example. Example 1, formation of sodium chloride. Formation of sodium chloride, that is NaCl. So one atom of sodium and one atom of chlorine will take part in the formation of 1 unit of sodium chloride. Sodium's electronic configuration is 281 and that of chlorine is 287. So in this case, electron transfer takes place. Transfer of electrons from metal to non-metal. Here sodium is metal and chlorine is non-metal. So here in this case what happens? Sodium has one valence electron. So for stability, it should have 8 electrons in the valence shell. So either it has to gain 7 electrons or it may lose 1 electron. So losing 1 electron is easier for sodium. Okay, so sodium is ready to lose electron. At the same time, chlorine requires 1 more electron. So chlorine is ready to take this 1 electron. So how do we show electron dot diagram? So 1 electron here because sodium has 1 valence electron and chlorine 7 valence electrons. Now if this electron comes here, automatically chlorine gets stability, sodium also gets stability. So this electron is going to be transferred from sodium to chlorine. So of this before transfer it is like this. After transferring sodium, it was 281, now this electron is gone, so it becomes 28. But sodium has lost 1 electron, it becomes positive. So it becomes a cation. At the same time, chlorine gains this electron. From here, this electron is going to chlorine. So already chlorine has 7 electrons here. This is compulsory, mandatory to show these electrons, and 1 is from sodium. Then chlorine gets negative charge. And now this becomes 288. So 8 valence electrons here and 8 valence electrons here. So that combination will remain stable. And this is how NaCl is formed. So sodium combines with chlorine in this way. Right? So this is the formation of sodium chloride. So in this case, what you have to remember is how many electrons are involved or how many electrons get transferred in the formation of sodium chloride. How many electrons? 1 electron. 1 electron transfers from sodium to chlorine. So this is the formation of sodium chloride. Similarly, we see formation of calcium oxide. Example 2, formation of calcium oxide. We know the formula, so writing the formulas here. Calcium oxide is CaO. CaO means 1 calcium atom, 1 oxygen atom. So calcium's electronic configuration is 28H2, oxygen 2,6. So this calcium has 2 valence electrons. We show 2 electrons here. Oxygen has 6 valence electrons. So 6 valence electrons we put 6 dots. Sorry, 6 cross. Because the dot I have used here. For calcium I am using dot. So for oxygen I have to use cross. Now these 2 electrons and these 6 electrons, if these 2 electrons comes here, both electrons, the pair comes there, oxygen becomes 2,8 stable, calcium becomes 288, that is stable. So these 2 electrons will be given to this. So this is before transfer of electron. Now after transfer of electron, so calcium becomes positive, but how many positive charges? It has lost 2 electrons. So plus 2 positive charges and becomes 2, 8, 8. So this is stable electronic configuration. And at the same time, oxygen already has 6 electrons here and 2 electrons are coming from calcium. So these 2 dots, because we have to denote that they have come from calcium. These 6 are cross and these two are dots, means these two electrons have come from calcium atom, and since it gained two electrons, charge will be negative and two electrons minus 2. So this will be 2 comma 8. This is also stable. 2 comma 6 will become 2 comma 8. So oxygen's electronic configuration is 2 comma 6, but O minus 2. Oxygen's electronic configuration is 2 comma 8. So here oxygen is gaining electrons. When oxygen is gaining electrons, it is called reduction. That also you have to remember. Simple process. Whereas calcium atom 2 8. Calcium atom is, before transfer of electron, calcium is 2 8 8 2. After transfer, it has become Ca plus 2. Okay, that is 2 comma 8 comma 8. It has lost electrons. Loss of electrons is called oxidation. So this is also very important. So what type of change that calcium undergoes, or what type of change that a metal undergoes in the formation of ionic bond? What type of change? Oxidation. What type of change that a non-metal undergo? Non-metal, like oxygen 2 comma 6, after gaining 2 electrons, it has become O minus 2. So this is gain of electrons. Gain of electrons. This is reduction. Okay. So loss of electron is oxidation and gain of electron is reduction. Metals undergo oxidation, at the same time non-metals undergo, metals undergo oxidation and non-metals undergo reduction. And last example, formation of magnesium chloride. Example 3, formation of magnesium chloride, that is MgCl2. So one magnesium atom, Cl2 means 2 chlorine atoms we are taking. We'll see why we are taking 2 chlorine atoms. Magnesium's electronic configuration 282, chlorine 287. This is also chlorine, same identical 287. Magnesium has 2 valence electrons, so magnesium is ready to lose 2 electrons. Magnesium is ready to donate 2 electrons, but each chlorine atom, 7 and 7 here. So each chlorine atom requires only 1 electron. This requires 1, this requires 1. So that's why with one magnesium atom, 2 chlorine atoms will combine. Okay, so chlorine has 7 valence electrons here, so we put 7 valence electrons. So remember, when you have 2 different elements, one element with dot, the other electrons are with cross. So one electron goes to this chlorine and the other electron goes to this chlorine. So this is before transfer. Now after transfer of electrons, magnesium becomes Mg plus 2 and chlorine, 2 chlorines are there. You need to show both the chlorines. Here, Cl minus 1 and Cl minus 1, and you have to show the electrons here because electron has transferred from magnesium to chlorine, right? So here already chlorine has 7 valence electrons, 1 from magnesium. Similarly here also chlorine has 7 valence electrons and 1 from magnesium. So now after transfer, magnesium has become 2 comma 8, chlorine 2 8 8, and this chlorine also 2 8 8. So this is how magnesium chloride is formed, 1 magnesium and 2 chloride ions. So now quickly we revise or we see the comparison between ionic bonding and covalent bonding. because definitely 2 marks question will come on comparison. Covalent compounds or covalent bond and electrovalent bond or electrovalent compounds, nothing but ionic compounds. So first difference already we have discussed, this is between non-metal, between non-metal, covalent bond is possible. Ionic bond is between metal and non-metal. So this is the first point. Second point, covalent bond is by mutual sharing of electrons. Mutual sharing of electrons. Here this is transfer of electrons. Transfer of electrons. Now when covalent bond is formed, it will give you molecules. So this is very, very important. Okay, what kind of particles are present in covalent bond or covalent compounds, molecules. In case of ionic bond, the type of particles are ions. And this point also very important. So what kind of force exists between molecules? Here between the molecules you will have weak van der Waals force of attraction. Weak van der Waals force of attraction, very, very important. And here strong electrostatic force of attraction. Strong electrostatic force of attraction between the ions, because we have ions here. Now since they have very weak force of attraction, this is a very weak force of attraction, they will have low melting point and boiling points. Low melting point and boiling point, because the attraction force is very less, you can easily melt them or boil them. But here attraction force is very strong, so they will have high melting point and boiling point. Okay, now coming to this, covalent compounds, usually we have two types, polar and non-polar. Polar covalent, soluble in water. Soluble in water, but non-polar covalent compounds insoluble in water. Okay, whereas in this case most of the ionic compounds soluble in water. Most of the ionic compounds are soluble in water. And when covalent compounds, we are talking about polar covalent. Okay, when you take polar covalent compounds, okay, 7 point. When you take polar covalent compounds, they get ionized. They get ionized in their aqueous solution, means in water. Okay, like for example, if you take HCl, HCl is a covalent molecule. HCl does not have any ions, but when you dissolve it in water, so now it will get ionized. Okay, it is forming new ions, but HCl does not have any ions, but when you dissolve it in water, it gets ionized. But in case of ionic compounds, they just undergo dissociation. Okay, see the difference between ionization and dissociation. Dissociation means, for example, if you take NaCl, sodium chloride is already an ionic compound, already it has ions, but the ions are held together by strong electrostatic force attraction. Okay, already ions are there. When you dissolve it in water, what happens? They just get separated. That separation is called dissociation. New ions are not formed, already ions are there, they get separated in case of ionic compounds. But in case of polar compounds, they get ionized when they are dissolved in water. Okay, so this is what the comparison between polar and non-polar. So the important points: one, what type of particles and force of attraction between them, and this, the difference between ionization and dissociation. Dissociation is just separation of ions. It is just separation of ions. Here ionization means formation of ions. They form ions. They form ions. Okay. Then we just see what is polar and non-polar. What is the difference between polar compound and non-polar compound? Because polar covalent compounds are water soluble, but non-polar compounds are insoluble in water. Let's see what is the difference between polar covalent compound and non-polar covalent compound. So when you take covalent compounds, like for example, are covalent molecules like chlorine bond chlorine. So here we know that both chlorine atoms, they are sharing a pair of electrons. Now what happens? We have learnt about some property called electronegativity. Electronegativity means the tendency to attract or attracting electrons towards itself. Okay, so electronegativity means an atom will be trying to pull the electrons when in combined state, like in covalent molecule. So in this case, what happens? Chlorine will be trying to pull these electrons towards itself, and this chlorine also will be trying to pull these electrons towards itself. So both will be fighting like a tug of war. Okay, so this chlorine is pulling it towards itself, this chlorine also pulling it towards itself, but chlorine atoms are identical atoms. So when they are identical atoms, both the forces will be equal. When both the forces are equal, the electrons will remain in the center. Okay, so these electrons, because they are in the center, the electrons are distributed equally. Distributed equally. Why? Because both are identical atoms. The electronegativity of this chlorine atom is equal to the electronegativity of this chlorine atom. So electrons are distributed equally. So this is called non-polar. This is called non-polar. Similar way, same way you have hydrogen bond hydrogen, oxygen double bond oxygen, nitrogen triple bond nitrogen. So these are non-polar. Now coming to polar. What is polar? In case of polar covalent like HCl. In HCl, hydrogen is contributing one electron and chlorine is contributing one electron. So now hydrogen will be trying to pull these electrons towards itself. Chlorine also will be trying to pull those electrons towards itself. But which one has more electronegativity? Chlorine is more electronegative. Chlorine is more electronegative than hydrogen. So obviously what happens? This pair of electron will slightly shift towards chlorine. Slightly, not completely. Because chlorine has stronger force, stronger pull. So this causes polarity on both the atoms. The one which is taking electrons becomes negative, partial negative, and hydrogen will become partial positive. So this is called polarity or polar covalent compound. Polar covalent compounds. That means here the electrons are not equally distributed. Those electrons are partially towards chlorine. So this is also very, very important. HCl, water, ammonia. Okay, so these are the examples of polar covalent compounds. Okay, so this is a quick revision on this chemical bonding. Okay, right. Hope you understand well. Let's meet in the next class.